A matrix is a rectangular arrangement or array of numbers, often called elements. Here are two examples of matrices. Notice how both matrices have 6 elements, but the arrangement is quite different. And this is why it's so important to understand the dimensions of a matrix. The size or dimension m by n of a matrix identifies how many rows and columns a specific matrix has. The numbers of rows is m and the number of columns is n, where rows go left and right and columns go up and down. So looking at this first matrix, it has 1, 2 rows and 1, 2, 3 columns, and therefore the dimensions of this first matrix would be 2 by 3. Comparing this to the second matrix, notice how this matrix has 1, 2, 3 rows and 1, 2 columns. Therefore the dimensions would be 3 by 2. So this is why it's so important that we understand the dimensions of a matrix. Notice if we consider a specific element in the matrix, for example this element here, notice how it's identified by a sub 2 comma 3, because the position of this element is row 2, column 3. And if we compare this to this element in the second matrix, we have a sub 3 comma 2, because this element is in row 3, column 2. Let's take a look at several more examples. We can see from these 4 examples, it's common to identify a matrix using a capital letter. So if we look at matrix A, notice how it has 1, 2, 3, 4 rows and 1 column. Therefore the dimensions would be 4 by 1. And often when identifying a matrix using a capital letter, as we see here, we'll often write capital A with a subscript for the dimensions, which in this case would be 4 by 1. This is often, and because this matrix has a single column, it can also be called a column matrix. If we look at matrix B, notice how it has 1 row and 1, 2, 3 columns. Therefore the dimensions would be 1 by 3. Because it has a single row, it's often called a row matrix. And if we identify this using the variable b, we'll often write the dimensions as a subscript, so we would have 1 by 3 like this. Looking at matrix C, notice how we have 1, 2, 3 rows and 1, 2, 3 columns. So the dimensions would be 3 by 3. Because the number of rows and columns are the same, this is called a square matrix. Or again, if we use the capital letter C, we would have C with a subscript of 3 by 3. Then for our last example, for matrix D, notice how we have 1, 2 rows and 1, 2, 3, 4 columns. So the dimensions would be 2 by 4. And again, if we use the capital letter D to identify this matrix, we would put the dimensions as a subscript, as we see here. I do want to end with a couple reasons why knowing the dimensions of a matrix is so important. As we already briefly discussed, the dimensions of a matrix must be known to identify a specific element in a matrix. For example, if we wanted to identify the element in row 2, column 1, we have to understand that that means we're looking for the element in row 2, column 1. So here's row 2 and here's column 1. So a sub 2 comma 1 would be equal to 9. Another reason is to add or subtract matrices, the dimensions must be the same. Notice how this first matrix is a 2 by 2 matrix, and the second matrix is also a 2 by 2 matrix. So because these dimensions are the same, we would be able to add these matrices. If the dimensions aren't the same, we cannot add or subtract the matrices. And then finally, to multiply matrices, the number of columns in the first matrix must be the same as the number of rows in the second matrix in order to perform matrix multiplication. So for example, this first matrix has 2 rows and 1 column, so it's a 2 by 1 matrix. The second matrix has 1 row and 3 columns, so it's a 1 by 3 matrix. And so we can only multiply these matrices if this number, the number of columns in the first matrix, and this number, the number of rows in the second matrix, are the same. And since they are, we can perform this multiplication. If they weren't, we couldn't. We will talk about how to perform matrix operations in future videos. Hope you found this helpful.